Alright, now that we talked about the derivative of inverse secant, it's time to do the derivative of the inverse cosecant. Okay, so ddx of cosecant inverse of x equals negative 1 over the absolute value of x times the square root of x squared minus 1. So notice this is just negative the derivative of inverse secant, alright? And we're actually going to prove this kind of the same way we did the inverse cosine. Okay, we're going to use the derivative of the inverse secant to do this. So first let's start by saying y equals cosecant inverse of x. Okay, that's an s. Okay, so y is the inverse cosecant of x. So this means x equals cosecant of y. Alright. And the complementary angle theorem from trig tells us that this is the same thing as secant of pi over 2 minus y. Alright, let's go ahead and get a thinner marker here. So cosecant of y is the same thing as secant of pi over 2 minus y, so that's one of the basic trig identities there from the complementary angle theorem. Anyway, so what we have now is x equals secant of pi over 2 minus y. Okay, so this means pi over 2 minus y equals the inverse secant of x. Okay. So now let's subtract pi over 2 from both sides. Actually, let's do it like this. Let's add y to both sides first. Okay, so we're going to have pi over 2 equals y plus the inverse secant of x. Okay, so now we're going to subtract the inverse secant of x from both sides. So when we do that, what do we have? Let's get a new color here. We have y equals pi over 2 minus the inverse secant of x. So now we just have y by itself. So on the other side we have pi over 2 minus the inverse secant of x. Okay. So y equals pi over 2 minus inverse secant of x, but also from here, y equals the inverse cosecant of x. So y equals that, and y equals this. So transitive property tells us that these two things have to equal each other, because they both equal y. Okay, so cosecant of x, so what we just found out was cosecant of x, or sorry, cosecant inverse of x, rather. Cosecant inverse of x equals pi over 2 minus inverse secant of x. Okay? So now, if we want to take a derivative, so let's take a derivative of both sides now. So ddx of inverse cosecant of x is going to equal ddx of pi over 2 minus secant inverse of x. Alright, and we know, what do we know? We can just differentiate term by term, right? So the pi over 2 is just a constant, so the derivative of that is 0. Right, and then we have minus the derivative of inverse secant. And what's the derivative of inverse secant? Well, we know from the last video, it's just 1 over the absolute value times, or sorry, over the absolute value of x times the square root of x squared minus 1. Okay, so ddx of pi over 2 minus that equals 0, because pi over 2 is just a constant, minus that, because this is the derivative of the inverse secant function. So then, you know, simplify, kind of, sort of, and then we just have negative 1 over absolute value of x times square root of x squared minus 1. And that's the derivative of the inverse cosecant function.